Hello friends, I welcome you to the chapter Antennas and Microengineering. In Unit 1 we have Introduction to Microsystems and Antennas. In this unit we will discuss today about Introduction of Microfrequency Bands and Antenna. So first, entering into the topic, we should understand about the chapter, that is Antennas and Microwave Engineering. In this course we have two parts. The one is antenna system and its design. The another one is microwave part. So in microwave part also we have microwave components, microwave frequency classifications and microwave design aspects, right? So in general, in this subject we have fundamentals of antenna systems, fundamentals of microwaves, and different components of antennas, different variety of antennas, microwave components are there, and the system design also available. So here first we should understand about what do you mean by microwave frequency band, what do you mean by microwave. The microwave, the term refers, split into two words. The one is micro, it refers smaller. The other term is wave, that refers wavelength. The frequency which is having smaller wavelength, that is called as microwave frequency. And then antenna. So antenna, we know that biological term, that is sensors, or it is used to feel something, right? So from this biological term, the same principle will be used in electronic terms. So in this chapter we will discuss about the basic classifications of microwave frequency and what is an antenna and its needs. So these are the today content. First one is evolution of radio waves and electromagnetic spectrum, microwave frequency bands, what is an antenna, why antennas, that is the need of antennas, right? And first we will discuss about evolution of radio waves. So we all know about Maxwell's equations, right? And Maxwell framed several equations, and those several equations are grouped into four major classifications. In 1873, the Maxwell framed the four major equations that we know already. After the framing the equations were experimentally proved by the German physicist, that is Heinrich Rudolf Hertz. Heinrich Rudolf Hertz is the German scientist. In 1885 to 1889, in this period, he proved all these experimental way, equations in experimental way. And after invention of the experimental way, the frequency is termed as Hertz. Hertz is the unit of frequency. The Hertz, the name derived from this German scientist Heinrich Rudolf Hertz. Heinrich Rudolf Hertz is the father of antenna systems. He is the first person successfully proves all these electromagnetic equations with the help of antenna systems. But it was not commercialized. The entire antenna system was commercialized by another scientist, that is the name is called as Marconi, in 1894 around. He is from Italy. So Marconi is the first scientist. He transmitted the electromagnetic signals in a commercial way, right? So this is the brief history about electromagnetic waves, or we can say that it's how the antenna system was developed. So this is the picture of Michael Faraday, and he's doing some experiment in his lab, right? So now we will discuss about electromagnetic radio spectrums, right? So in this picture, the first part is about the size of reference of the wavelength. Okay, so first one is football field. The football field is the very bigger space. When we compare with the end, it is atomic nucleus, it is very small tiny particles. So this much space is required for completing one full wavelength whose frequency range is very less. Okay, around 1 megahertz, if we convert this 1 megahertz into wavelength in the form of lambda is equal to c by f, we have one full cycle will complete within this football field. So it is a bigger size of wavelength, right? So this is the complete football ground takes to complete one full cycle of on and off. When moving towards this direction, the wavelength will be narrow, it is very small, but this is the frequency range. The frequency range here it is very less. So both are inversely proportional. If the lambda is increases, f will decreases, right? So lambda is equal to c by f, where c is the velocity of light in free space. So in free space, the velocity of light is equal to velocity of electromagnetic spectrum. Okay. So see here, this is the wave whose length is very much longer. When we move towards here, what is happening? The wavelength is very much narrow. So during this range, whose frequency is very smaller, and toward this, the frequency range is very high. Here low frequency and high frequency. So we know that during high frequency, the wavelength will be very smaller, and whose size is very small, that is around the size of atomic structure around. Here the frequency is very small and whose shape is around, it's a bigger, right? It is around football field sometimes. And the third part is electron volt, so energy level of the corresponding signal. And the energy level here it is very less during the low frequency. Towards this end, whose energy level will be high. And because of these electron volt, that is energy level of such frequency range, we are classifying this electromagnetic spectrum into two major parts. See here, the green color part is completely non-ionizing radiations. The yellow color part is ionizing radiations. So according to the biological effect, we are classifying the entire spectrum into non-ionizing radiations and ionized radiations. What do you mean by non-ionizing radiations? Non-ionizing radiations does not make any harmful except heating, right? Just it will make surface heating. If we use the mobile phone, or if we use if our skin is radiated for a long time, right? So under this range of frequency, it will induce some surface heating. It does not make any more that much harmfulness for any living organs. So after this much electron volt, see here, this much electron volt, 10 to 10 power 6 electron volt, it becomes ionizing radiations. Once the radiation penetrates the layers or any living organs, what will happen? Because of this high energy level, the ionization happens, and because of the ionization, it may damage the cell structure of any living organs. So sometimes it may damage the DNA structure also. So this is called as ionizing radiations. Ionizing radiations whose energy level will be very greater when we compare with the lower level, right? And this is the last one is the usage of such frequency bands, right? So frequency band can be classified into radio spectrums, microwave spectrums, and this is the light mediums, and this is we have X-ray and gamma rays. So X-ray, gamma rays will be used for different purpose, for scanning, PET CTs and other medical purposes. And this visible spectrum, we have different light, energy and other parts. And this low frequency of that is terahertz range of frequency, which is used for screening purpose. And these all from 10 power 5 to 10 power 11 hertz, the frequency range is used for multi-purpose, example for commercial applications, communication systems, Wi-Fi, WiMAX, satellite communications, microwave ovens for cooking, and radio communications, radar, mobile. There are a lot of things. So all these, we are using all these communications nowadays. So this is the brief introduction about electromagnetic radiation spectrums. So this is the same picture, it is in detail, right? So now we will move on to this clear picture of the frequency range starts from 3 megahertz to 3 gigahertz. The spectrum is called as radio waves. Radio waves are nothing but the signal which starts radiating from the channel or radiating from the conductor. That is called as radio waves. After radio waves we have microwaves. See, the frequency range starts from 3 gigahertz to 300 gigahertz. Within this 3 gigahertz to 300 gigahertz we have lot of classifications of the frequency band. So in the next slide we will discuss about how we have classified this microwave frequency range. See, here starts from the designation L band. The L band starts from 1 gigahertz to 2 gigahertz, whose wavelength is around 15 centimeter to 30 centimeter, and it is used for different purposes. For example, military telemetry, GPS, mobile phone, GSM, amateur radios, all these things. Similarly, we have classified from 3 gigahertz to 300 gigahertz with different bands. The first band is L and second band is S band, 2 to 4 gigahertz, and the third band is C band. It is for long distance radio communications. Whereas in the S band we are using nowadays for all these applications, right? We are using mobile phone, we are using wireless LAN, Bluetooth, Zigbee, GPS, all other things, right? So all microwave devices, microwave ovens also we are using this frequency range, 2.5 gigahertz we are using in microwave ovens. So this S band is nowadays we are using for all the commercial applications. This is very, very important. We are using now for all the commercial mobile, internet, whatever we have. Then we have C band, it is for long distance radio communications. X band frequency is higher than this. For C band we have 8 to 12 gigahertz. Most probably students will be using in the laboratory about these X band frequencies. And the third column is it's completely about the wavelength. You know how to convert from frequency to wavelength, right? And then the micro frequency further classified into KU band, K band, KA band, Q, U, V, all these things. Sorry. So that's all about micro frequency band and the classifications, right? Now we will come to the point of antennas in biology. So in antenna in biology, how we can term, right, these antennas. Antennas are our electronic eyes and ears on the world. Okay, our ears and eyes are the sensors. Okay, through that we are receiving some communications, right? So this is the biological terms. So similarly, the antennas are used in several animals to sense or to feel some objects. So according to the part, the animal will change the direction, or animal will work further, right? It will move further. So these are the portions, organs, we can say that this is the biological antenna which is used to sense some particles. According to the signal whatever which received, and through these antenna systems here and through this antenna system here, the animal will change the directions, or animal will get some informations. Similarly, we have antennas in electronics. So we are connected globally through antenna systems, right? So I am taking class from my residence, and students will be sitting in their own residence. How we all are connected? Through electromagnetic. Not only electromagnetic through antenna systems. So along with antennas and electromagnetics, we all are interconnected together, right? So this is the basic fundamentals. What do you mean by an antenna? Antenna is nothing but it is a conducting material. It is in the form of wire, rod, or any shape, right, which excite electromagnetic information. So any shape of metal piece, it can be a wire shape, or it can be a circular shape, it can be any kind of shape. It is going to excite electromagnetic signals. So the electromagnetic signals will be the informations, right? So the antennas are connecting devices in a free space. It will act as a source for the receiver. It will act as a radiator for the transmitter, right? Antennas are sensors of electromagnetic waves. Antennas are the transducer because it converts electrical information into electromagnetic, or electromagnetic into electrical information. So this we can say that it is a transducer. Antennas can match the impedance, right? Antenna is going to match impedance of free space to this information, right? We can say it is a impedance matching device. Antenna is a coupler. It is going to couple the information from generator to the free space. or from free space to the generator. So we can say it as a coupler. Clear? So antenna is nothing but it is a any shape of metallic piece, metallic rod, metallic wire. It's going to sense electromagnetic signals. Clear? So here I would like to show some examples of antenna systems. See here, these are the antennas are connected as array systems. This is also some example of antenna systems. And here we have this is the antenna systems in our nearby place. It is located in Chittoor. It is one of the division of ISRO India. The laboratory name is called as NARL, National Atmospheric Research Lab. It is located on the via of Tirupati to Chittoor. So this is the biggest array we have in our country. So here the each and every element is nothing but an antenna systems. It is grouped together, so it becomes an array systems, right? And this is another type of biggest antenna in our country, that is R.M.K project. It is located in Bangalore. And this is another antenna system, GMRT systems, which is located in Pune. And this is the antenna setup in mobile phones, right? In mobile phone we have lot of applications. So for lot of applications we need there are different band of antennas. One is for Wi-Fi applications, and GPS antenna systems, NFC antenna systems, and this is the main antenna systems, right? So because we are going to access for several applications, so we need several antennas in the mobile phones. And what is the need of an antenna? What is the need? Where it is used? So without antenna, what will happen? Suppose if I communicate within a classroom, right? Within a classroom, if I communicate to the students, we no need of depending any equipments to transfer my information to the students. Clear? No need of any equipment. But at the same time, if you want to communicate for long distance students, wireless communication is established, for example. So how we have to communicate for long distance? We need to go for antenna systems. So within short duration between short time between short distance between your transmitter to the receiver part, destination part, we no need to go for any system to communicate, right? And see here, if you want to communicate from this area to here or this area to here, okay, right? See this, all these people are interconnected with the help of the antenna systems, right? So if the distance is longer, we have to go for antennas. Clear? Right. And antenna systems are used to connect the people globally, and there's a lot of applications nowadays. We are living with antennas always, you know. Every day we are carrying antennas, right, in the form of mobile phone. Inside the mobile phone we have antenna systems. So nowadays antenna is everywhere, right? In the medical field, see here, in the medical field, the doctor will monitor the patient through the antenna systems, and 24 hours it is possible to monitor the patient, or we can with the help of other country we can able to access this, we can use the applications, right? So from here we can monitor the patient from London or somewhere else, or from London doctor will monitor the patient from India. So similar way, it is very much useful for wireless health monitoring system is possible because of the antenna systems. And through mobile app we can monitor the health condition of patient, and this is the wireless cardiac pacemaker to simulate the heart functioning, right? So this is the example of pacemakers. So antenna nowadays it is used for several applications. Nowadays we go for agriculture systems, medical field, traffic systems, or communications. Wherever you go, we have all these systems are connected with antennas. So in order to establish very good communication. So these are the pictures which shows that the usage of antennas for different organs. For heart it is the pacemakers, and here one pills are fixed sorry, fixed within the brain to simulate the local area, and here the antenna system is fixed in the pancreas, and hearing aids, and here we have for improving the eyesight. All these parts where antennas are playing a vital role. So there are multiple applications nowadays we have. So with this we will wind up the today class.